Hello everyone, myself Girish N, second year MSc Chemistry, JSS College, Ooty Road, Mysuru. In this video, I am going to explain determination of relative equivalent mass of the weak organic acid by acid-base titration. Then acid-base titration is a method of quantitative analysis for determining the concentration of an acid or a base by exactly neutralizing the standard solution of base or acid having a known concentration. A pH indicator is used to monitor the progress of the acid-base titration. Before going to perform the experiment, let us see these terminologies related to the experiment: aim, principle, procedure, reagents required for the experiment, analysis. Let us see one by one of these terminologies. Aim of this experiment is determination of relative equivalent mass of the weak organic acids by acid-base titration. The principle behind this experiment is when an acid is titrated with sodium hydroxide at the equivalence point is nothing but the millimole of acid is equal to millimole of NaOH. The amount of NaOH at the equivalence point will depend on the number of replaceable hydrogen atoms of the acid. Hence, the number of replaceable hydrogen of the acid is given by N. N is equal to millimole of NaOH divided by millimole of acid. The reactions taking place based on the principle of this experiment: acetic acid plus NaOH resulting in the formation of sodium acetate with sodium salt of acetate plus H2O. Acetic acid is a monoprotic acid, hence it contains only one replaceable hydrogen atom. It requires only 1 mole of NaOH. In the case of oxalic acid, it is a diprotic acid. It requires 2 moles of NaOH. Now moving on to the procedure of this experiment: weigh of 1 gram of weak acid, dissolve and make up to 100 ml standard volumetric flask. Pipette out 10 ml of this weak acid solution from the standard volumetric flask and transfer to 50 ml titration flask. Add 2 drops of phenolphthalein indicator. It is titrated against 0.1 normal solution of NaOH taken in the burette until the end point is colorless to pale pink color. The second part of this experiment is standardization of given approximately 0.1 normal NaOH solution. Prepare 0.1 normal PHP solution and pipette out 10 ml of this solution to 50 ml titration flask and add 2 drops of phenolphthalein indicator. Titrated against NaOH solution taken in the burette until the end point is colorless to pale pink color. Repeat the above process for 2 to 3 times to get a concurrent value. Reagents required: 0.1 normal NaOH solution, 0.1 normal potassium hydrogen thalate is nothing but PHP solution, phenolphthalein indicator. Preparation of solutions: preparation of 0.1 normal PHP solution. Weight of PHP required is calculated using this formula: normality into volume into equivalent weight of PHP divided by 1000. Next, weight of PHP taken, note down the value. Next, moving on to the concentration of PHP. 0.1 into weight of PHP required divided by weight of PHP taken. Using this formula, we have to calculate the concentration of PHP. Next, moving on to the standardization of approximately 0.1 normal NaOH solution. Burette contains approximately 0.1 normal NaOH solution. Conical flask 10 ml of, we already calculated the concentration of PHP in the previous step using the 10 ml of this PHP solution plus add 2 drops of indicator. Indicator is phenolphthalein. Endpoint is colorless to pale pink color. Next, we have to carry out the titration process. Note down the initial burette reading and final burette reading. Using this reading, we have to calculate the concentration of NaOH solution. The formula is N1V1 is equal to N2V2. Is nothing but normality into volume of NaOH is equal to normality into volume of PHP. We have to calculate the normality of NaOH is equal to normality into volume of PHP divided by volume of NaOH. The main analysis of the weak organic acid and calculation of equivalent weight. This is the main Important aspect of this experiment: preparation of 1% solution of weak acid. Weight of the weak acid taken, note down the value. Weight of the weak acid is equal to weight of the weak acid taken into 10 divided by 100. Using this formula, we have to prepare the 1% solution of the weak acid. 1% solution is nothing but 1 gram of solute per 100 milliliters of final volume. 1 gram of solute is dissolved in 100 ml of water. In the burette, we already standardized the NaOH, so concentration is known. Take this NaOH solution. Conical flask contain 10 ml of the weak acid solution plus 2 drops of the indicator. Indicator is of phenolphthalein. Endpoint is colorless to pale pink. Carry out the titration process. Note down the initial burette reading and final burette reading, and calculate the volume of NaOH consumed in this experiment. After the completion of titration process, we have to calculate the equivalent weight. So millimoles of the weak organic acid is equal to millimoles of base. It's nothing but volume of acid into normality of acid is equal to volume of titrant into normality of titrant. Millimoles of the weak acid into equivalent weight is equal to weight of the weak acid taken is nothing but W. Millimoles of the weak acid is nothing but volume of titrant into normality of titrant. Hence, equivalent weight is equal to weight of the weak acid taken divided by Vt into Nt. Using this formula, we have to calculate the equivalent weight. W is the weight of the weak acid taken. Vt is the volume of titrant in the above titration process recorded. Normality of titrant in the constant standardization of NaOH. The value is put it onto this equation. Then we get the equivalent weight. The final step of this experiment is result. The report